Hello, Physics 3310 students. We're going to talk here about Fermi problems or order of magnitude calculations. Why is it important for you to be able to do this? Well, there's quite a few real-life applications where you can really use order of magnitude calculations. If you are ordering equipment for your project, you will need to know the sensitivity required for detecting the result in your project. So you can do some order of magnitude calculations to figure out a range. So you can pick out of the list of different voltmeters, for example. Or what approximations you can use to precisely determine the outcome of your project. You can also do some estimations to check the feasibility of your project. Is it even possible? Is it affordable? Are things available? You can also do a sanity check on your final answers with a quick order of magnitude calculation. And you can compare that to the more precise calculation or result of your experiment or work. So Fermi was known for his ability to make these sorts of order of magnitude calculations. A famous example is that at the Trinity test, he was able to estimate the strength of the atomic bomb by dropping paper from his hand during the test to see how far it got pushed by the blast. So based on that distance, the distance traveled by the pieces of paper, he was able to estimate that 10 kilotons of TNT were used, with the real actual number being 20 kilotons. So he was able to estimate that quite well. Okay, so when you do order of magnitude estimates, you are supposed to not use a calculator. Like, that's the whole point, is to make it very, very easy. And you also don't look up exact numbers, because you want it to be an estimate. So don't look anything up, and don't use a calculator. So in that case, what we do to make that possible is to let numbers turn into, we use estimates for certain numbers to make them easier to calculate. So pi is 3, and e is 3, and the square root of 5 is 2. And that's the kind of math we're talking about here. The exact answer is unimportant because we're order of magnitude estimating. 2 times 10 to the 25th or 3 times 10 to the 25th, who cares? It's 10 to the 25. Okay. Okay, so Fermi's famous problem was, how many piano tuners are in Chicago? We're going to calculate this without a calculator. I mean, estimate without a calculator. So what we have to figure out is what we don't know. We need to make a list of things that we would need to know to answer this question. So there are other questions that are first important before we can answer that final question. Like, how many pianos and how many people does it take to tune those pianos? And then we'll answer those questions. Okay, we don't know how many people are in Chicago, but we can estimate that. It's a big city. And we can maybe estimate there are 3 times 10 to the 8 people in the USA. Or whatever. We're not looking anything up, we're just estimating. So actually, let's see what we can, determine about Chicago. New York City is like 15 million. DC, Baltimore is like 7 or 8 million. So Chicago is a little bit smaller than those cities. So that's 5 million. So order of magnitude. We have, on the order of a million. So how many pianos do 5 million people own? Let's see. Maybe 1 out of 100 own a piano? How many people do you know that own pianos out of all the people you know? Unless you're a piano enthusiast. I'd say 1 out of 100 seems reasonable. Okay, and then I think maybe we can, start from another perspective. We can think maybe 10% of people play an instrument. Maybe a third to a fifth of those people play piano. And not all those people can afford one, so that's about 1% of the population. So about 1% out of that 10 can afford a piano and play piano. So that is 1 times 10 to the minus 2 pianos per person. 1%. So we have 5 million people, and 1 times 10 to the minus 2 pianos per person. That's 5 times 10 to the 4 pianos, or 50,000 in Chicago. How many piano tuners does it take to tune 5,000 pianos? How often do they need to be tuned? I guess more than once a decade, and yeah, less than once a month. Maybe once every year or every couple years. How long does it take to tune just one? Probably 2 hours. Less than a day, more than 30 minutes. Maybe around 2 hours to tune a piano. On the order of 2 hours. So, with all the keys and strings and stuff, you might need actually 2 to 3 hours of piano. Alright, I'm going to make a couple changes to that slide there. So, what is the number of piano tuners in Chicago if we know there are 50,000 pianos in Chicago? Let's assume one piano tuner works 40 hours a week for 50 weeks a year. So that's 2,000 hours a year per tuner, and each piano takes 2 hours to be tuned per year, like we said in the last slide. So that means a piano tuner can tune 2,000 divided by 2, 1,000 pianos a year. Okay, so if we have 50,000 pianos, and one piano tuner can tune 1,000 pianos in a year, then we would need around 50 piano tuners to be in Chicago for there to be enough piano tuners for that amount of the steady state. All right, so we found an answer, 50. So that exact number, yes, is worthless. The order of magnitude is important. It's on the order of magnitude of about, 10. It's not 0.1. It's not 10 million. It's about 10 times 5. So we don't really care if it's 55 or 50. Anything smaller than a factor of 2 doesn't really matter. But a factor of 2 you should actually pay attention to, because that's half of an order of magnitude, or 4. So let's think about the realness, the not applicability, but the trueness of our, the accuracy of our result. 50 is between 25 and 100. That's probably true, pretty close to what the real number is. Even more so, I'm very sure that the number is above 5, 2 orders of magnitude, smaller than 50, and smaller than 500, which is 2 orders of magnitude bigger than 50. And I'm really, really sure that 3 orders of magnitude less than 50 0.5 nanotuners is that there are the number of tuners is between 0.5 and 2 orders of magnitude bigger than 55,000. So we got to a correct range with our order of magnitude estimate example. So here's what you do, just as a reminder, you figure out the big questions, outline the logical steps, estimate where you can, try not to look things up, and then think about your answer. Does it make sense? These are also called back of the envelope calculations because they can be done, in the middle of a professional lunch or something. You always want to get, of course, a second opinion from another scientist, or compare your first answer to another answer from a different sort of point of view. Make sure those values agree. All right, I hope you have enjoyed the Fermi problems lecture. Have fun with your Fermi problems.